Chapter 11, Lesson 4 is areas of regular polygons and composite figures. Okay, our learning targets for today, or what this lesson is about, we're going to be finding areas of regular polygons, and we're going to find areas of composite figures. Now we're going to start with a regular polygon. And recall from chapter 1, a regular polygon is both equilateral and equiangular, which means all sides are congruent and all angles are congruent. In our picture, we have an example of a regular pentagon, and all regular polygons can be inscribed in a circle. So notice this circle is circumscribed about my regular pentagon. There are some important parts of our regular polygon. The first, we have the center of a regular polygon, and the center of the regular polygon is the same as the center of the circle. Okay, the radius of a regular polygon is also the radius of the circumscribed circle. So notice the radius goes from the center to the vertex of a polygon. The apothem is a segment drawn from the center perpendicular to a side of the polygon. So here's our center. Okay, there are 5 sides to choose from. I can draw an apothem to any of the 5 sides, and it goes from the center and is perpendicular to one of the sides. Okay, last we have a central angle. Remember, a central angle is an angle formed whose vertex is at the center of the circle and sides are radii of the circle. Okay, so the central angle for my regular polygon is the same as the central angle of a circle. Okay, and if we want to find the measure of that angle, we would take 360 degrees divided by the number of sides of our polygon, and that would tell you how many degrees that central angle is. Now we're going to use this information to find the area of a regular polygon. Now I'm going to take my pentagon and redraw it. Okay, so here's my pentagon. It's again inscribed in a circle. And there's a couple key parts that I'm going to draw in. First, I'm going to draw in all the radii. So here's the center. There are 5 radii in a pentagon going from the center to each of the 5 vertices. This creates isosceles triangles, and a pentagon has 5 isosceles triangles. A hexagon would have 6 isosceles triangles. A square has 4 sides, would have 4 isosceles triangles. Well, the apothem, the distance from the center perpendicular to a side, is the height of one of those triangles. So a pentagon has 5 apothems, all representing the heights of our 5 congruent isosceles triangles. So if I want to find the area of a regular pentagon, I am going to find the area of one of these triangles and then multiply it by the number of triangles that is within the polygon. Now, a short way of finding the area of a regular polygon is using the formula area equals 1/2 AP, where little a represents the apothem and capital P represents the perimeter. We are also going to find the area of composite figures. Okay, a composite figure is just a picture made up of smaller shapes. Okay, so it is a figure that can be separated into regions that are basic figures. So for example, this is a composite figure, and it can be created using 3 rectangles. Okay, this is a composite figure. Okay, and is formed by a triangle and a semicircle. And again, to find the area of composite figures, I would find the area of each of the smaller basic figures and add them all together. All right, let's turn the page and let's look at a few examples. Okay. Example number 1, area of a regular polygon. We're going to find the area of the regular pentagon. Now, rather than drawing in and finding the area of each of the triangles in the picture, we're going to use our formula, area equals 1/2 times the apothem times the perimeter. Okay? In my figure, the apothem is given. It is the distance from the center to the side. So my pen is running out. So the apothem is 5. It's the height of one of the triangles. The perimeter is the distance around the outside. Because it is a regular pentagon, all sides are congruent. So that means all sides have a length of 6. So the perimeter can be found by multiplying the length of the side 6 by the number of sides 5. So my perimeter is 30. So to find the area of the regular pentagon, area is equal to 1/2 times the apothem 5 times my perimeter of 30. Okay. We'll probably need a calculator for this. Okay, 1/2 is 0.5 times 5 times 30, and the area is 75. Okay, I do not have any units, so it would be 75 units squared. Letter B, find the area of the regular polygon. Okay, the formula for area of a regular polygon is 1/2 times the apothem times the perimeter. In my figure, the apothem is given at 14.4. The length of one side is 13.9, and I need to determine how many sides there are. So I'm going to start with 13.9. There's 1, 2, 3, 4, 5, 6, 7 sides. This is a heptagon. So to find the perimeter, I would take 13.9 times 7. I'm going to use my calculator for this. Let's see, 13.9 times 7 is 97.3. So my perimeter, 97.3. So to find the area, go 1/2 times the apothem, 14.4, times the perimeter, 97.3. So I'm going to take 0.5 times 14.4 times 97.3, and the area is 700.56. Again, I have no units, so I could just call it units squared or just leave the units blank. So this is how you find the area of a regular polygon given the apothem and a side length. Okay, I would like for you to pause the video and try letter C. Okay, we're going to find the exact area. Okay, attempt the problem, and we will check it when we meet in class in person next time. Okay. Now, review of special triangles. Don't forget, for a 30, 60, 90 degree triangle, we know that the short leg times radical 3 is equal to the long leg, and 2 times the short leg is equal to the hypotenuse. For a 45, 45, 90 degree triangle, I believe I have that incorrect, it is my leg times radical 2 is equal to the hypotenuse. Now we're going to use this information to find the area of regular polygons that are a bit more challenging. So let's go to example 2. Look at problem number 1. We are going to find the area of the regular polygon. Now remember, area is equal to 1/2 times the apothem times the perimeter. Okay, I am given that the length of one side of my equilateral triangle is 14. So I can find my perimeter. Okay, if each side is 14, and there are 3 sides, I want to take 14 times 3. Okay, multiply that on a calculator, 14 times 3, and the perimeter is 42. Next, I need to find the apothem. Okay, the apothem is this height. Now, what I'm going to do is I'm going to draw in the other radii, and this creates one of the 3 congruent isosceles triangles. I need to find the measure of a central angle. Again, I need to find the measure of a central angle. To do that, I'm going to take 360 and divide that by my 3 triangles, and each central angle is 120 degrees. Okay. Now, the apothem cuts the central angle in half. Now, if I take half of 120, then this angle up here is 60 degrees. And if this is 90, then I have a 30, 60, 90 degree right triangle here. Okay, I'm just redrawing that a little larger. Now, the apothem also cuts this side in half. So the length of my longer leg right here is 7. I need to find the apothem. Okay, now recall in a 30, 60, 90 degree triangle that the short leg times radical 3 is equal to the longer leg. Well, my short leg is the apothem times radical 3 is equal to the longer leg of 7. So to solve for A, I'm going to divide both sides by radical 3. So the apothem is 7 divided by radical 3. I need to multiply by radical 3 over radical 3. I have to rationalize the denominator. This is equal to 7 radical 3. Square root of 3 times the square root of 3 is the square root of 9. And the apothem is 7 radical 3, all divided by 3. Okay. So my apothem, 7 radical 3, all divided by 3. Okay, so to find the area, I have 1/2 times 7 radical 3, all divided by 3, times my perimeter of 42, and if you want to, you can put 42 over 1. Now I'm going to multiply straight across but give an exact answer. So 1 times 7 times 42. 7 times 42 is 294. So I have 294 radical 3 in my numerator. 2 times 3 times 1 is 6. If I take 294 divided by 6, I get 49. So my exact area is 49 radical 3. This would be meters squared. These are very challenging. These are taking into consideration a lot of different things that we have learned this year. Okay. All right, problem number 2. I have a hexagon, a regular hexagon. I know the area is equal to 1/2 times the apothem times the perimeter. My apothem is given at 5 radical 3. I need to find the perimeter of the hexagon. Again, it may be helpful to draw in a couple of radii so that we can see our congruent triangles. And I need to find the measure of one central angle. To find the measure of that central angle, I'm going to take 360. Since it's a hexagon, it has 6 sides. It also has 6 congruent triangles. 360 divided by 6 is 60 degrees. So this central angle is 60 degrees. Now, the apothem cuts that central angle in half. Okay? So what I have, the triangle that I just made in red, is a 30, 60, 90 degree triangle. So here's my apothem at 5 radical 3. Okay, this angle right here, which is half of 60, is 30 degrees, which makes this a 30, 60, 90 degree triangle. And my apothem is the long leg. I need to find this short leg right here. So I know that the short leg times radical 3 is equal to the long leg. Now, I just called my short leg x, and my long leg is 5 radical 3. So to solve for that short leg x, I'm going to divide both sides by radical 3, and x is equal to 5. Now what that means is the length from here to here is 5. So the length of a whole side is going to be 5 plus 5, which is 10. So to find the perimeter, hexagon has 6 sides. Each side is 10 units. 6 times 10 is 60. So the area is equal to 1/2 times the apothem, which is 5 radical 3, times the perimeter of 60. I'm going to give an exact answer, so I'm not going to mess with the square root of 3. So I'm going to take 1/2, or 0.5, times 5 times 60, and I get 150. So the area is 150 radical 3 centimeters squared. Okay, I would like to try one more problem. Okay, problem number 3. Okay, in problem number 3, we have a square. I need to find the area using my formula. Area equals 1/2 apothem times the perimeter. Okay. Now I understand you can find the area of a square by taking base times height, but I'm going to show you this so you see what type of triangle is formed, because most of the time we're not going to give you the length of this side. We're going to either give you the apothem or we're going to give you a radius. Okay, so area equals 1/2 apothem times the perimeter. Now I can find the perimeter. Each side length is 15. A square has 4 sides. Multiply 15 by 4, and the perimeter is 60. And draw in 2 radii to create some additional triangles. We need to find the measure of this central angle. So we're going to take 360 divided by the number of triangles, which is the same as the number of sides. 360 divided by 4 is 90 degrees. Okay. So this angle right here is 90 degrees. Now, the apothem cuts that central angle in half. Okay. So this red portion of the triangle is going to be a special triangle because half of 90 is 45. So this becomes a 45, 45, 90 degree triangle. Now the apothem also cuts that side in half. Okay, so half of 15 is 7.5, and we know that in a 45, 45, 90 triangle is an isosceles triangle, so that means my apothem is also going to be 7.5. So A is equal to 7.5. So the area using our area formula, 1/2 times the apothem times the perimeter. So I have 0.5 times 7.5 times 60. We get 225. Okay, I would like for you to try problem number 4. Okay, you're going to want to draw the picture and just do your best. Okay, we will attempt these problems and go over the you try problems next time we meet in class, and then go through lots of examples together. Good luck.